Hello class, I want to talk about the next topic on waves in the textbook. This is about standing waves, and we're going to talk about aspects of standing waves. Now imagine I had some span of rope from here to here. Let's pretend each of these blocks represents a unit. So this is like 12 units long. And if I was holding my rope tightly at both ends, we could consider these fixed or rigid positions. So say with the flick of my wrist, I send a pulse from this end, like so. And I want to give this crest a width of 6 units, roughly. So this crest, with the flick of my wrist, let's say it travels in the rightward direction as such. Now when it gets to this end, it's going to reflect back. And because this is a fixed position, the reflection is going to be inverted. So I'll draw the same amplitude in the opposite direction, and I'm going to call that I'm making this in such a way that this reflection is, let's say, it doesn't lose any energy at the boundary. So very little energy is transmitted at the boundary. Almost 100% of it is reflected, and it's inverted because this is fixed. So it has about the same amplitude in the opposite direction. So it'll be traveling in this direction. If I'm making these pulses with some sort of regularity, a moment later, we would have my incoming pulse wavefront would be around here, and a reflection would be about here. And we were talking about superposition in an earlier lesson, but at that moment, these two amplitudes, they're going to cancel out. The superposition of the wave, then, will result in it having an amplitude of this equilibrium here. However, this will travel past this wavefront, and then this one will be over here. So a moment later, you'd have the blue incoming wave here and the orange reflected wave here. For any given moment then, we're given a standing wave. For this first moment, the standing wave is going to look like this. Because this amplitude here cancels out this amplitude here. And what it's going to look like is this will alternate here, but we'll still have no well, I should say this should be orange. This orange wave will be over here in one moment. So it'll look like we have a crest here, a trough here, and then a crest here. This one will be blue in the next moment. But this crest and this trough will alternate positions, That's what's known as a standing wave. And we get this for certain produced wavelengths in maybe a fixed boundary. If we were holding the positions fixed at this boundary and this boundary. Standing waves are pretty important, and they have notable features. So, for example, here, here, and here, there's no displacement, okay? Locations of no displacement, amplitude is 0, those are called nodes. So what I'm going to do is I'm going to point at them, bring them down here. Those are called nodes. They're points of zero displacement, or locations. Locations of no amplitude. All right, awesome. But then what about what's going on here, 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 and here? Depending on the time, it's going to be looking like the crest becomes a trough and the trough becomes a crest and vice versa. It's always going to be changing. What do we call those? Well, if those are called nodes where there's no amplitude, we would call these antinodes. So we would call those maybe locations of max amplitude. Now you're going to get standing waves when incoming waves and reflected waves undergo interference in such a way that you get points where there's no movement. Even though this crest is always traveling rightward, even though this trough is always traveling leftward, if the conditions are just right, and in terms of wavelength, for any given medium that a standing wave can be produced, certain boundaries, the boundary is a certain distance from the other. If the conditions are just right, you do get these sort of standing waves. And I'm going to do a second video where this is animated for us. But all standing waves will have these alternating crests and troughs and these locations of no amplitude. So just remember then, nodes are locations of no amplitude. Antinodes are locations of max amplitude. I hope this has been helpful. Watch out for the next video. But until next time.